Welcome back to Simply AI, a place where I explain all the complex and treated AI concept in a simplified and easy to understand manner. Let's move on to this session, which is going to about linear regression implementation using Python. So in our previous session, we have covered linear regression with one feature, and we have covered gradient descent algorithm and linear regression one feature implementation using Python. If you guys haven't watched that video, I will provide video link in a description. You guys can go and watch that. Before moving to this session, we're just going to do the quick recap of previous session. So in previous session, we know that we have a training set where x is the input and y is the output, and we represented that x as an input size, which is our input, and output is the output price of the houses. Similarly, we have one hypothesis, and we are going to use the hypothesis to predict, our house price. So during the prediction, we are going to use our new theta 1 and new theta 0. How do we get new theta 1 and new theta 0? We have the loss function, and we will minimize that loss function, and by which theta this loss function is going to be a minimum. We will say this is our final theta, right? So this is how we calculated our loss, and each time we received the theta using gradient descent, we calculated the loss, and we saw that the loss is getting decreased, correct? So this is our loss function, and this is the main step where we calculate theta. So we do one iteration, we get our new theta, and then we check what is our loss, and we just keep doing this step again and again until our loss is a minimum. So I will not go deep into the coding part which is written here. If you guys don't understand this, I think you guys can go and watch previous video where I have explained each and every step. Now this is the complete overview, and there are only 4 sections of code, and using these 4 sections of code you can just write simple linear regression algorithm for one feature input. So first let's try to implement for 2 feature, and then we will try for the multiple feature later. So I have already written the program, so I will just explain this. So these are the library which is needed, and here I have added the one more parameter, which is the input number of rooms, right? So right now there are two inputs. The one is the input size, and another one is the input number of rooms, and output price is going to be our output. So if you will see, all the the steps are matching, and it should always match. Otherwise, you will get error of index not found or something like that. So just make sure that steps and shape of your input and output are aligned. Now instead of 2 parameters this time, we are going to take the three parameters. The one is the theta 0, because now our hypothesis is going to be a theta 0 x0, where the x0 is 1, plus theta 1 x1 plus theta 2 x2. So there is going to be theta 2 as well for x2 feature, and x2 means the input number of room feature. So that's why we have taken here the 3 parameters, theta 0, theta 1, and theta 2. So as you can see that this is our hypothesis. So see, this is going to our hypothesis, just like theta 0 plus theta 1 into x1 plus theta 2 into x2. Now let's just visualize this data and just see how this data looks like. So I have used the matplotlib for plotting the the points. Since this is the 3D version, I'm going to take the 3D axis, or projection is going to be a 3D projection. Now here, first I'm just scattering the data. So there are 3 types. The one is the input size, another one is the input number of rooms, and our z-axis is the output price. So this is the x-axis, this is the y-axis, and this is the z-axis. And as you can see, these points are scattered here. Okay. And then we are showing display. So this is just the output of your whatever the the points which you have, or the input data which you have. Now what I want to do, since we have the theta 0, theta 1, and theta 2, I want to see what my initial hypothesis looks like. So in our previous example, since we have only 2D plane where the the x is the input and y is the output, when we draw our initial hypothesis, we got the line, right? But this times we have 2 parameters. The one is the size of the house, and the another one is the number of rooms. So we have two parameters and one output parameter, which is the the price of the house. Since we have two parameters here, our initial hypothesis will look like a plane. So to draw the plane, what do? We will just take the x from 0 to 25, and then we take the y from 0 to 25, and then we will just do the mass grid. And what it is going to do, we just read out. So basically, it is just going to convert into, if they are 12 by 1 matrix, it is going to convert it to 3 by 12 matrix. And then we have written our j or g, which is theta 0 plus theta 1 x1 plus theta 2 x2, which is x and y in this case. And then we are just plotting this and with green color. So let me execute this, and you can see this. Okay, so this is our initial hypothesis or initial plane. Now, in our previous example, we saw that we trained the theta, and then our line is getting close to our input plottings or whatever the plotting we have done. Here you can see this plane is going to move towards this data. Let me just try to make it in one graph. Let's say. Okay, and I'll just remove this instead of here. I'll write this here. So as you can see, this is our plane and these are our points, right? So now you can see the points and plane in the same graph. So these are the points and the plane is far from these points. So once we start training, this plane is going to move towards the point. So let's calculate the loss. So this is going to our initial loss. So as you can see here, we are taking all the three parameters, theta 0, theta 1, theta 2, and then we are calculating the initial hypothesis minus the output, and then we are squaring it because we want to calculate the squared loss, and then we are doing the sum, and then whatever output is going to come, we will say this is our square loss. This is exactly the same as our previous example. We just added one more feature. I just wanted to show you, the visualization of the 2D, because after then, if we have the three features, we cannot visualize it. We cannot draw the graph for three features or the four features or the n number of features. So that's why I just showed you for the two features, and after then we will just directly jump to n number of features. Okay, so let's move on to the gradient descent. This is exactly same. I just want to do the few changes for visualization so that we can visualize better. And I'll just take this kind of things. Okay, so this is exactly the same what we have done earlier. So I will not explain this step by step. So this step is going to perform the sigma, and then here we are performing the gradient descent for each of features. And after the 1000 iteration, or 1000 are too much, just take the 50 iteration for now. After the 50 iterations, we will just calculate the loss, and each time we'll see how does our plane look like, and after that we'll draw. So let's execute this code. Okay, so as you can see here, right, this was our initial plane. Okay, don't look at plane right now, it's messy. If you will see the loss, this was our initial loss, and after each iteration our loss is getting decreased, right? After 40th iteration the loss is 686, and our initial loss was 14,000 something. Okay, you can just change the alpha and change the iteration, and you can play with parameters. I'll just take the two iterations so that I can just show you how this plane is moving towards the data, and just or towards the input parameters. Okay, so as you can see these are the points, right? And our plane was this. If you'll see, our loss is like it's almost half. It was 14,000, and then it was only 9,000 just after one iteration, and our plane moved from here to here. If you just take the three iteration, so this is how our plane moved. And this was the first one, and then second one, and then this is the third one. So now you can see how this plane is moving, and our loss is getting decreased every time. So this is how it happens. So once you will get your final theta or theta 0, theta 1, theta 2, you will use those theta 0, theta 1 or theta 2. Here I have assigned those values in new theta 1, new theta 2, and then you can use that value to predict your house price. You can just say, hey, my house size is this and number of rooms are this, and I can predict your price is going to be this much based on this plane, correct? So this was about the implementation of two features. And if you guys have any doubt on this, you can comment it down. I will try to reply over there. Okay, so now let's move on to our next agenda. In previous example, we added new variable for the number of rooms in house. But suppose if we have the n number of features, we cannot have the n number of variable, or we cannot just keep adding variable in our program. So to address that issue, we are going to follow the vector approach, and that vector approach is called as a normal equation as well. So normal equation allows us to reach minimum just by one steps. So in a previous example, we have done the gradient descent, and uh, we did this on 50 iteration, right? And like that, we can have the as many iteration as we want. But normal equation is something different. Here, we can get our theta just by one step. So let's move on to this, and we'll just quickly cover the normal equation. And I'm hoping that you guys are, you guys have the basic knowledge about the algebra and how do we do the derivative of algebraic function. So let's talk about how do we represent everything in matrix here. So this is how our input matrix is going to look like, and this is our output matrix or output column vector. So let's talk about the basic notation here. So here this is the our input matrix and this is our output matrix. So you can say that your hypothesis s theta of x is going to be x transpose theta, right? And then x theta minus y is going to be a hypothesis minus y, and like that. So since we are interested in our loss, which is the squared loss, and we know that if you're doing the g square in vector, it's going to be g transpose into g. And how we are saying this, I think I'm going to upload the video of the basic algebra, and I will describe this there. For now, you can just search it on a Google, and you will get the explanation of this term. So since we are interested in our squared loss, so our squared loss, which is s theta of x minus y whole square, right? So which is going to be 1 by 2 x theta minus y transpose into x theta minus y. So this is our z theta in terms of vector. We have the x input matrix, we have y, and we have our j theta, which is this one. And now, in this matrix, we don't know the dimension of the theta. So let's talk about what should be a theta. Theta dimensions. When I'm saying dimension, means it should be what should be a number of rows and what should be a number of columns. So we know that x is n by m matrix, and we know the y is n by m matrix. So this x theta, the result of the x theta should be n by 1 matrix, right? Then only you can do the minus algebraic operation. So for that, the theta should be, what should be a theta dimension? It should be m by 1 matrix. So when you do the dot product of n by m dot m by 1, you will get n by 1 matrix. And after then you can simply do the algebraic operation. And the transpose of that matrix is going to be 1 by n. And the result of this is going to be n by 1. And after then, if you do the dot product of these two, you will get the one value, 1 by 1 matrix, which is going to be one value, and that will be your loss. We are going to do the programming of this as well, which is very easy to do. So like this, we have input, and we have this output, and then we have this theta, and theta is nothing, it's just a random random values. But here we don't have one values. Here we have the the matrix of random values, and that size of that matrix is the m by 1. And our loss function will look like this. So here you can see that first we have one variable temp, and here what we are doing x theta minus y. So the dot product between the input and theta, and then the minus output. So it is x theta minus y, and then here it is np dot transpose temp, and then we are multiplying again with temp, and then dividing by input dot set 0. So whatever the loss is coming here, because if you will calculate the size of loss, it will be 1 by 1 matrix. That is why you're just taking the value of loss 0 0. So whatever value you will get here, you'll just return that, and you'll say this is your loss. So this is how we will calculate the loss. Now the how do we calculate the derivative? Because as per gradient descent, right, we want to calculate the derivative of j theta. Let's talk about one simple example. So suppose A is this matrix a11, a12, and 21, 22. It's a 2 by 2 matrix, and this is f of A. So this is f of a. There are few terms which are related with your matrix A. There might be few constants as well, right? And now you just want to calculate the derivative of f of theta with respect to A. And that is what our requirement is, right? We want to calculate the derivative of g of theta with respect to theta. So here we want to calculate the derivative of f of A with respect to A. Let's see how it will look like. So here, when you will calculate a of 1, so as per this formula you can see, when you will go for the the a11, you're just going to do the partial derivative of a11. So the partial derivative of a11 of this function is going to be 3 by 2, and these terms are constant, so these are going to be 0. And then and and when you will go for the a12, these values are going to act as a constant, and only this value is going to be derivate, which will be at 10, a12. So similarly we will do for the g of theta. So derivative with respect to theta 1 by 2 x theta minus y transpose into x theta minus y. So once you will you'll just do this step by step, which is explained here. You will get this term. I will not explain this. You can do in rough or in paper. Just remember that in matrix, whenever you are doing, suppose this is just a normal product, but instead of, suppose you're doing here x theta, right? So instead of x theta square, you're going to write it as x theta transpose into x theta. So then you're doing the scalar product, you're just doing the square, but when you're doing the vector product, you're going to do the that x transpose x instead of this square. So just remember that, and I think that will be enough to get this value. So here you can say your derivative of j theta is x transpose x theta minus x transpose y. Okay, so now you have a derivative of g theta, and you want to minimize it, and you can see the minimum value can be a 0, right? So 0 is the one when your you can say your slope is a minimum. And if it will be a 0, then you can just say that x transpose x theta equals to x transpose y. And then theta value will be, this term will go here, and it will be x transpose x inverse x transpose into y. Okay, this is not the y cube, this is just the y. So here, x transpose x inverse x transpose y, there is no theta. That means you can just say that you can get the value of theta without having any initial theta. I mean, you can just calculate the value of theta using x and y, right? And that is what your requirement was. You just wanted to calculate the theta, and here you have theta. So that is our final parameter, and there is no iteration needed. Now let's see how do we write program of this. So we have the in NumPy we have the library called the linear algebra, which is the LINALG, and that library has the function inverse. Using that, you can find out the the inverse of your matrix. So if you will compare this term to this coding terms, you can easily correlate that. It's very easy. So first you are doing the transpose of the input, which is our x, and then you're doing the dot product with input, which is the nb dot dot with input, and then you're calculating the transpose, then you're calculating the inverse of this term, and then again you're doing the dot product with transpose, and then you're doing the dot product with output, and then you are doing the dot product of this term and this term. So that is what your theta is. It's pretty simple, right? If you have any doubt or any question, you guys can comment it down. Let's try to write code for this. So I have already explained the line by line code here. You guys just you can just stop the video and just relate with the formula. But okay, let's go to program and see how does this work. Let's go to linear regression vector program. So I have already written the program. I will just go through it. So these are the libraries which is needed for this program, and those are like our NumPy, matplot for plotting. We're not going to plot actually, so we do not need matplot this time. We need the random, and we need the pandas. So why the pandas? So panda has the very good support of reading the CSV file or Excel file. So most of the time you will get, if the the data is numeric, most of the time you will get the data in CSV and Excel file, and you can use the panda library to to get those data from those file, and then you can just convert into NumPy. And even in pandas, panda also they have very good operations or matrix operations. So if you want, you can use that also. So here we have the data, which is called the boston.csv file. Let me just open this data once. So this is how this data look like. So it has a lot of data. I think total number of rows are 507, and these are the columns which have. So it's like the zone number of house, and what is the tax, and what is the age of house, number of rooms, and area. So this data has all the correct detail. I have downloaded this file from the Kaggle. In next session, or probably next to next session, we are going to do the one Kaggle problem. So for now, you just understand that this is the real data. Okay, so we have taken the real data, boston.csv, we uploaded this, and if you want to just print the the top 4 rows or 5 rows, you can just do the data.head. So we use the pandas.read CSV to read this CSV file, and we have given the location of the file, and then we are just printing the 5 rows of that file. So this is what we will get. So this is our data. Okay. Here I have printed few things like the save 0. So when we have printed data.save, we got this 50615. So it means we have the 506 number of records, and we have 15 columns. In that, the first column is just the index column 1 2 3 4, so we do not want to take that column. Okay. And then in second, okay, in the last column is our price column, so that is our output, and rest other columns are our input data. So we create first, we are just, because the type of data is here the pandas.core.frame.data frame. So just to convert that data frame to NumPy array, you can just pass this data into np.array and then again assign that to data. So now your data type is the np.array, right? So your input is 0 to 506, which is, this is just the slice. How do we do the the slicing in NumPy? So here we are just taking 0, or the first row, to 506 rows, and we are taking 1 to 14 columns, right? We are just leaving this 0th column, which is just indexing. We are taking 1 to 14 column, and that is our input. And output, we are taking all the rows, and we are taking only the last column. This is our output. Now this is just the printing of input data. This is how our input data will look like. This is output data, and this is the input save and output save. Here I have removed the matplotlib because we cannot visualize the data. Here we have the n number of columns. So here we have some 13 or 12 columns. So we cannot draw the 12 axis and find out how does our data look like. We simply cannot do that. So the only thing is left is to we calculate the loss and just figure it out whether loss is decreasing after each iteration or not. But since we are talking about the normal equation, here we will get our direct theta, and we will just compare what was our initial theta and what is our final theta. So now this is the theta, and theta size is going to be input.save 1, 1, and we have already talked about this uh, in our slide. Why theta size is this, right? This is going to generate the random values of theta size 13, 1. So if you will see, our input size was 506, 13, and you can just say that we need 13 theta, or we need 1 theta for each variable, correct, or for each feature. So that is why the theta is 13, 1. So this is our theta, so just theta. And now this is our loss function, and we're calculating the loss function by this formula, where we were just doing the x theta minus y transpose into x theta minus y, and this is our initial loss, which is some 54,000 something. Now this is the normal equation formula, that inverse formula, and if you will see, if you will do this, you will just get our final theta, and then we are getting our new theta by calling the normal equation, and then again we are printing our loss function, or a loss after new theta, like what will be a loss using the new theta. So let's run this, and our loss is 24. So directly from 54,000 to 24, no iteration needed. So the question is, why don't we use normal equation all the time, and why don't we prefer normal equation? The reason behind that is, we have taken the the data which has the very less number of training set. It was just a 506, and this terms in normal equation, where we are doing the inverse of this matrix, it's very costly. The complexity of this term is the O of n cube, and here the doing inverse is costing us O of n cube. And if our the matrix size is going to the big, if our data, or the training size or number of features is going to big, this inverse is going to take too much time. Okay, so that's why we don't we don't use the normal equation. That is the one of the reason we don't use the normal equation. The another reason is, if you will see our Boston data, right? So this data is a pretty if you will see, all the numbers are small numbers. It's like 4 or 65 or 6.5 or 0 point. These are not like 6,000 or 6 lakh or something like that. Why, if you have suppose data like that, and when you do this thing, like you're doing the dot product, and you're summing up, and then you're doing, I mean, you're doing so many mathematical operations. So there are high chances of your value getting out of the memory. Or suppose your matrix is the matrix of integer or matrix of float, but whatever you are getting after the doing the dot product or something, that value is too big and you can just not store. So that is why the kind of data which you choose is also very important. So here, if you will see, I have two files. One is the Boston.csv and the another one is the housing.csv. So if you will see housing.csv, it has all the big values. So what I'm just going to do, I will just read the data from the housing.csv instead of the the Boston.csv. Okay. So this is the housing.csv file, and this also has all the longitude of location, latitude of location, the age of the house, the total number of rooms. We will see. I mean, they have the 80 rooms or 7,000 rooms, which does not make any sense. But you know, I mean, there is the probability when you get the data like this. Maybe uh, not in housing data, but it can be some other kind of data. So you're just doing this, you're getting this value, and then you're, as for that, you're taking some random theta, you're calculating the loss, and you're getting the error. You're getting the error because when you're doing the dot, you're getting the value which you cannot handle. So that is why the data filtration and all those things comes where you choose how should be your data, so that your model works for that data. It, it does not break. So you need to make sure. So I think your job does not start from creating the model. Your job is start from preparing the data, and after then the creating the model comes in a picture. So I think these are the reason. Because of these all those things, we don't use the normal equation too frequently. So the only case when we use the normal equation is when you have the less number of training example, less number of features, and the values in those training examples are not so big. Then you can use the normal equation, and it's going to be pretty fast. You just do not need to do anything. It's just a writing a formula. Why to use gradient descent if we can use normal equation? I think we are clear on this. Normal equation is not going to work everywhere, but the gradient descent or the previous approach is like evergreen approach. You can use whenever you want. If it's little lengthy, it's going to take time, but that's not a problem. Okay. So the next session, uh, a better way, we are going to discuss a better way, which is the this mix of vector representation and our iterative approach. So if you would have remember in our iterative approach, we just created the theta 0, theta 1, theta 2 like that. But in our next session, we are going to discuss how to take the data in matrix instead of the single array, and how to approach the or how to implement the iterative approach on those metrics instead of just applying the formula which we have tried here as part of our normal equation. So that is what we are going to discuss, and that's a better way to do it actually. And after then we are going to do the one linear regression problem in Kaggle. And then there is the another approach which we are going to discuss, which is the more towards the probability and statistical uh, approach. So that's going to be theory, and whatever we are going to derivate over there is exactly the same what we have learned so far. But that's very important for our next topics or for our future topics. Okay, I think we are done here. If you guys have any doubt or any question, uh, please comment it down, and I will try to answer over there, or maybe I will explain the answer of that question in my next videos. And yeah, thank you very much. Please do not forget to like this video, share, and subscribe it. Thank you. Thank you very much.